In this video, we're talking about alkyne synthesis, and we're going to make a new carbon-carbon bond. This is the first time you've learned how to make a new carbon-carbon bond, which is super exciting. All right, so again, I also don't expect any of you to be as excited about all the stuff you're learning. I'm just really excited, so maybe some of it will rub off on you? I don't know. Anyway, this is an acid-base reaction followed by an SN2. Notice here we keep combining these reactions we've learned. This is a very common thread in all of your organic chemistry career where you're just really combining reactions you already know. Let's take acetylene and we're going to do an acid-base reaction. We're going to react this with sodium amide. So this has a negative charge here. Now, if we think about the pKa's, we know the pKa of the most acidic proton here on acetylene would be around 25, and it's 1 here on the end. Each one has a pK of 25. And we're going to do an acid-base reaction where we're just going to deprotonate. And then we made NH3. Okay, now the pKa of amines are typically 35. And in particular, ammonia has a pKa of around 38. This reaction is irreversible. Okay, so we need a really strong base in order to do this. So when we're looking at this, oh, and I should also note, this, I call it sodium amide. You can also call it sodium amide. Just depends on who you talk to. So when we're looking at this, we know that this carbon with this negative charge here, it's a pretty good nucleophile, but it's also really good base. This can do SN2 or E2. In order for us to favor SN2, like we've talked about before, we're going to use a carbon primary alpha carbon here. So let's use iodide. We'll mix it up a little in this video. So primary works. Or you could use a methyl, so like a methyl iodide. Depends on what you're trying to make. So we're going to use this propyl N-propyl iodide. And the mechanism here is just an SN2 reaction. Now when we draw a product, I always like to count my carbons out because otherwise it's really easy to lose track. Actually, this carbon 3, I'm actually going to put it on the thing we attached. You can use any kind of numbering system. We're not doing this for IUPAC, simply just to keep track of everything. And you'll see why I put a 3 there. But you can do whatever works for your brain. So we have our 1, 2 carbons. This is bound to 3, 4, 5. And you can write out just to make sure you don't lose carbons. I highly suggest this technique. It's so easy to forget carbons. Now keep in mind, we really have a good base. We've got a carbon with a negative charge, and this sp hybridized carbon, it is a very good base, but also a good nucleophile. So let's just make a note. So secondary or tertiary alpha carbons would give E2 as the major product. E2 elimination products as the major products. So this really only works for primary, or if you have like a methyl with a leaving group. Okay, and I'm going to make one more side note here. This drawing of the alkynes, just remember that if I draw it like this is wrong. Remember that alkynes here, this is an sp and an sp carbon, so these are linear. Okay, you need to make sure you draw them in a linear way. And let's make a note about a wrong thing for this, for the base that we formed. If I were to draw this would be wrong. So you could maybe put your lone pair here and put a negative. So what's wrong with this one? Well, actually, if I count my carbons, this is saying I have 1, 2, 3. It says that this there's another carbon here, when actually we only have 2 carbons. So this line that's extended in the middle is signifying another carbon, which means this is a negative charge on an sp3 carbon. So what you want to do, this is wrong, so don't draw it like this. You can draw your negative charge at the very end of the triple bond, so make sure that you stop drawing that middle line, and that will be the correct way to do it. So this is alkyne synthesis, and again, we're just using acid base followed by an SN2, and it only works for the primary end methyls with the leaving group. This is, again, it's extending your knowledge about synthesis, and you'll start to use this more and more as we keep going through our material. All right, that's it for this video.